Learning about security doesn't need to be scary.
If you want to ship code securely with confidence, check out the URL below and challenge yourself with thousands of challenges in 29 coding frameworks. Let the games begin.
And we have Seth Law talking about the absolute AppSec secure code review framework. I'm really looking forward to this one because I think it's very, very much needed because it's all over the place. All right, can we welcome Seth?
All right, very good. Thank you very much. You should all be looking forward to this. This is the too long didn't read version of Seth and Ken's Excellent Adventures in Secure Code Review. This is the training course that Ken and I put together. We were here last year. We were here this year teaching people how to conduct secure code reviews. Part of the whole reason that we've come up with this framework, well, we'll get into it more momentarily, right? First of all, by ways of introduction, I'm Seth Law. I run a small consulting firm. It looks really big up there, but it's small. Redpoint Security. We do application security, consulting, and research. That's basically it. There's me and a couple others that are more portion of that. Absolute AppSec is actually the podcast that Ken Johnson and I run. Ken's at CKTricky on Twitter. I'm at Seth Law on Twitter. We have both been doing application security for a number of years. I've been in the industry for 15 plus years. And the framework came about because we noticed a dearth of discussion on actual recommendations for performing code reviews. We've got a lot of training courses and other things that are out there that are very specific to languages and frameworks. Like you can go do a course on secure coding in Java or Node or Python or all of the different languages and frameworks. But as penetration testers, application security professionals, product security people in an organization, we don't necessarily talk about what we do on a daily basis. Like it's great to know what SQL injection looks like in a Java application, but if we don't have a process that we can go through and actually identify what's in there, we're all just going to be doing different things. It's going to take one assessor or one reviewer a much longer time to get through a code base because they don't have some sort of a framework to work with or a methodology to use when they are conducting a secure code review. We have a lot of courses also around like penetration testing, how we do some sort of dynamic assessment, the steps that we go through, but we don't have a lot of that for secure code review. I think a portion of this is because it's hard, right? So everyone's going to repeat after me here, right? Reviewing code is excellent, right? Yeah, finding vulnerabilities is always fun. And I get this all the time. I'm talking to friends and family, and they're like, "Oh, you're a hacker, right?" That's always what they say. And I'm like, "No, not really, but sure. If that's how you want to understand it, that's what I do." And then they say, "Well, I'd love to come and sit in your office and watch what you do on a daily basis." And I'm like, "No, you do not want to watch me. It is incredibly boring." My kids, they come in and all they see is dad looking at, a black screen and a bunch of code day after day after day. So it is excellent. There's a lot to it, but it does take discipline, and that's what the framework and this methodology is about, is giving you the discipline that Ken and I have accumulated over the last 15 years to actually get through something and actually find these vulnerabilities. So the whole philosophy behind it here is that we want to increase the likelihood of success in finding vulnerabilities. This doesn't mean that you're going to find every bug imaginable. That's just not realistic. There's other ways to go about that. This complements dynamic testing. It complements bug bounty and the other security activities that we have. But what we want our success to be is some sort of a focused, comprehensive, timely assessment or review of the code, and we want it to be something that's language agnostic. So I should be able to apply my methodology to C code that's used inside of a kernel for a library or a web application or a mobile or an IoT application. If I can't do that, it's not a repeatable process. All right. Yeah. So the other thing here is it's to focus on what's important. I mean, we've all seen this, right? We're in Australia, the rhinos that come down. This is what it feels like as a consultant, kind of on a daily basis, is I get turned over, 3.2 million lines of code, and they're like, hey, you have 2 weeks to look at this and actually find something. So approaching that really becomes an exercise in distilling it down into some sort of a prioritization, right? I've got to be able to identify the pieces of the code that are important from a security perspective and aren't as and actually affect something so that I can find those vulnerabilities, right? The approach that we take is, realistically, ideal world would I have as much time as possible, right? Ken works for GitHub. This was a portion of what he was able to do for a number of years until they got acquired by Microsoft, and now he doesn't have as much time as he wants for everything. The second one there, oh my God, please no, right? Like I have no time at all. I've done assessments before where they've handed me, 500,000 lines of code and said, hey, here's 2 days, go. And it's almost, it feels like I go back to the rhino, right? You've just been hit by a bus. Real world, most of the time, I'm able to set the scope a little bit as a consultant, or if you're embedded in an organization, you're performing some sort of review, you should be able to at least define something reasonable. And reasonable is going to depend on you and also kind of your experience with the code base. Like the less time that I've had with a code base, if I haven't seen it before, I'm going to build in some extra time for the methodology, and we'll talk a bit about why that is. But if I've seen it before, it's easier to slim that down because I know what I'm already looking at. The one thing you notice that none of these are just run a scanner and analyze the results. My first couple of years spent as an application security consultant, this was the sort of review that we were pushed into time after time after time. And they kept calling it a secure code review or a, secure source code review. We're like, no, this is not what this is. Static analysis does not equal secure code review. If you take one thing away from this today and our discussion today, this is what I want you to take away from it. It doesn't mean that the static analysis tools are not useful and don't give us good information and can point us in specific directions. But if I run like AppScan source of Fortify and get 50,000 results and it takes me 2 weeks just to analyze the results that came out of the scanner, I haven't actually analyzed the code base for security. There's things that the scanners miss that you can identify fairly quickly as a person, as a human. And yes, they'll get better at identifying some of the business logic flaws and other things like that. But in general, a secure code review goes back to the creativity of the reviewer, right? And the experience that you have. So none of the reviews that we were doing here are just run a scanner and analyze the results. All right. So let's actually talk about the methodology a little bit. Really? Okay, we're done, right? Everybody saw this and we can go? No? All right. It distills down to a fairly common set of items, right? What we want to do is perform, information gathering about the application, a bunch of checklists, and then perform the reviews. There should be documentation down here too, but we're not too worried about that. You can talk to your developers. You can figure out how you're going to report on things, and we do have some examples of that in the framework. And I'll tweet out a link to where these slides and the framework documentation exists if anyone wants to use it. I mean, hopefully you're here, so you actually want to use it. That's the whole point. But so you don't necessarily have to take pictures of everything. Realistically, though, like performing these reviews, creating this checklist, this is very important. I mean, we've got all these checklist items that we think about when we are performing the review. The issue that we've run into time and time again when performing these secure code reviews is that we have a tendency to jump to this phase, right? Raise of hands, how many people have done a secure code review or a code review in the past? All right. So what is the first thing you typically do in a code review? I can't hear anyone, so. What, Pam? Huh? grep, yes. And this is the typical problem that we have. We're used to finding vulnerabilities, so we're like, hey, we grep and we look for, like select star, right, or a select statement for SQL injection, and all of a sudden we found like 500 instances of the application actually making a call to the database, and we start jumping down SQL injection, right, before we even understand what the application does. That's bad, right? All that does is means I went down the rabbit hole. I'm going to spend 3 days looking at SQL injection. I've only got 10 days to analyze this source code. And then I'm going to pop my head up and go, oh crap, how does this application even identify users? And so what we want to do is make sure that we spend the time up front during these, this application overview, this information gathering phase, to wholly understand the application. And this realistically doesn't take a lot of time, and it pays dividends, in spades as you move through the review itself. Okay, so in practice, we take that list, that methodology list, and we use this Circle K framework to actually, implement it time and time again. The first thing that we're going to do is open a file and take notes. Take copious notes. If you asked me what application or what happened in the application I reviewed 2 weeks ago, I could not tell you. Right? I've seen so many applications over the course of my career that, something that was 3 or 4 months ago, I have no chance of even remembering what technology or framework or what the application did. So without the notes and without this record of what I've actually done, it's very difficult to go back and, talk to the developers about it. But realistically, so we open a file, we take notes, we actually tag things like the commit number, everything else that we know about the application. We get to know the application's purpose, map it out, brainstorm risks, and then we build a list of review items. We do all the reviews and we double back. Right? This is the activities that we're going to be doing on a daily basis, and it's going to be based around these items here. So, so this is what we will be doing. This is the methodology that we're imprinting upon that. So we'll talk to that. So before we get into each of those different items, though, I wanted to talk about general code review principles. Those that Pam was in our course, so we've discussed this before. But any idea what the recommendation is from the development industry on the number of lines of code that should be examined in an hour during a code review? How many do you think? Yell out a number, someone. 10? That's a little low, but yeah, if it's Ruby, probably right. How many? 200? That's close. They say no more than 400 lines of code. 400 is the absolute maximum that you should review. So if you've got 2 weeks and you've got 3.2 million lines of code, I'm going to get to like 1/100th of that if I'm following those recommendations. So what we have to do is distill it down. So if I'm reviewing 400 lines of code an hour or 500 lines of code an hour, which is optimistic, I need to identify the security relevant pieces of the application, and that's what I can use. Now, once I get towards the end of the application, or once I get towards the end of the review, I'm probably going to do something like use grep, right? At that point, there is an appropriate manner that we can use that. But at first, I want to make sure that I've identified those relevant pieces. So I'm going to use these principles to actually implement the framework. I'm going to work in small chunks, like 1 to 2 hours. If you're staring at code, it doesn't matter how much caffeine you have. After about 3 hours, you're just done. It doesn't matter. Yeah. So you have to stay on task with the current objective. This is the really difficult thing to do. This is what we even have a problem with when Ken and I are working in the course and with students, is it's very easy to be like, hey, that session object, that looks really interesting. Well, maybe we should spend another extra time in that, even though we're just mapping out the application at any specific time. One thing that I don't have up here that I did want to mention is use the, this portion here, right? Build the code, run the unit test, ask questions, framework code documentation is your friend. We recognize that as reviewers and developers, right? If you're trying to build the application, you become a lot more familiar with the internals of it, what the requirements are, what the dependencies are. I can't tell you the number of times, though, I've seen security people and security consultants, try to pull up a Java application in, like Atom or something like that, rather than using Eclipse and the IDE that was used to build the application. If you want to give yourself a leg up on the tools that are used by the developers, use the same IDE that the developers use to develop the application. Okay, so that's general code review principles. Note taking, I kind of mentioned this already. Here's an example of, we've got a template that's out there that we actually use, as a consultancy, and I know Ken uses one as well at GitHub. We've kind of, each of us have customized it a little bit. This is example notes from a review that we've done of a vulnerable or of a task manager application. But you'll notice we've got the commit number right at the top. Obviously, that becomes important if you're talking to a customer about, hey, this is the code base that we've actually assessed. So if something was introduced after that commit number, I haven't looked at it, just gives you some sort of an accountability factor there, so you don't get blamed for something you shouldn't have, or maybe you can be like, hey, yeah, I did miss it. But realistically, what we'll do is we'll build out our behavior. The template exists. Like I said, I will link to all of this. The number of risks that are in the application, and then the checklist of items that we want to look at within that code base. If I expand further down in these note-taking, you'll see a list of like all the endpoints that I could possibly identify within the application, all the files that are of importance, authorization decorators, so all the other things we're going to talk about. And I do apologize because, right, we're 15, 20 minutes into this. Again, we teach this as a 2-day course. The first day is all talking about theory here, so we're going to get through as much as possible before we end today. So, so note-taking, that's just a simple example of the notes that we take. And now we'll jump into the actual methodology itself. So application overview and risk assessment. There's a couple of, so we could classify the first couple of steps in the methodology as information gathering, but we did want to separate it out a little bit because we've got kind of your technical information gathering, which is the second step in the methodology. And the first step is actually just getting to know what the application is. Why is that important? If you don't know what the application is intended for, it's really hard to tell you what the risks are. It's actually really hard to jump into it. And I do have this is all based on Bill and Ted's Excellent Adventure. So if you haven't seen it, we could just screen that instead. It'd probably be good for you, but they're doing another one. So first off, the first thing we want to do when we pull up an application is build an overview of what it actually does, build a portrait of that application. Whether that's the behavior of the application, what it's intended to do, the technology stack that it's associated with, some app archaeology, right? Has anybody ever ever run a Git log and just look through that for security events? Yeah. I mean, there's usually some interesting things. I always love that, I removed an AWS key, right? Because they had pushed that into Git. Guess what? Hey, that's a great thing that you can go pull back out. It's probably still relevant if they just removed it. So you're going to perform all these sorts of functions right off the bat. You're going to step away from grep for a little bit and from the tools that you normally use when you're performing the review and actually get to know the application. A portion of this, when it comes to technology stack, is going to be reading documentation. If you're not familiar with the language or the framework that's being used, go to the source and actually figure it out. I've spent time, especially when it's something that's popped up over and over again, like a new framework, say like Elixir at some point. We analyzed an Elixir application that's Erlang. The first thing that I had to do was actually go to the documentation and build a Hello World application. So I made sure I understood how it was intended to be used. And that was all done as part of the code review process to help me understand it. I could have easily jumped in and looked at a security checklist for Golang and started to attempt to identify the security vulnerabilities in the code. But having the understanding before I actually jumped into that, into the code base helped me in the long run. It made sure that I felt more complete about what was going on. So we're going to build a portrait of the application. We're going to ask what the application does, who it does it for, what kind of roles it includes. As a consultant, I get a lot of this information out of the scoping document initially, but developers are usually pretty friendly about this as well, and they'll drop it into the README. right, associated with a code base, or they'll put it into other places. The one thing that's most interesting here is this final question, right? What aspects concern your clients, customers, staff the most? So a couple of years ago, I was doing an assessment for an organization, just as an example of this, and found SQL injection, right, in this one web service that was, being hit up by a React front end. I was able to actually dump out the whole database using SQL map, and I was like, sweet, this is awesome. Get on a call with the developers, and I'm like, hey guys, I found SQL injection. Before I could say anything else, the lead developer pops back and he said, hey, did you find it here? I was like, yep, I found it there. He's like, yeah, that's old code. We knew about it, right? And I'm like, so I spent like 2 or 3 days like tracing this down and figuring out how to make it work. Whereas if I had just asked this question, he would have told me, hey, that's old code over there. Spend some time there first and tell me that it's bad so I can go to my management and say, give us time to actually fix it. I mean, overall, it worked out for them, but that's the reason that we ask this question. You want to be involved with the developers. We want to understand what their concerns are because they know where code doesn't pass the sniff test. Like you will as well as kind of developers and as reviewers. As you're looking through something, you want to pay attention to that, the sniff test, right? Does this pass muster or does it feel bad? And that's one of the things that the tool's never going to find. So make sure and ask that question if you don't have access to the developers or the organization itself. See if you can at least kind of pass that back and forth, right? Whoever is responsible for giving you that code should answer this question for you. We're going to analyze the technology stack at this point. We're not going to dig too deep. The whole point here is to know what framework and language is being used, right? It's pretty easy when it's, Django, Python, or Java, Spring, whatever it is. But we want to know what that framework and language is, what the specific version is that's targeted, so that we can start to look for things like OpenCVEs, known issues with that. And that goes to third-party libraries as well, like any of the components that the application depends upon. If we have a list of that, it's going to be easier as we jump into the different aspects of the application. We're performing our review on authentication. If it's using a third-party library for authentication, that takes a little bit of the pressure off because we know, hey, this is a vetted third party that's actually being used to handle usernames and passwords. Or guess what? This has 1 star on GitHub. That's probably not something that we should be using in our production application for authentication. So realistically, you're just trying to figure out how the application accomplishes its purpose. What pieces it uses to do that, what versions of the code or the frameworks they're using there. Data store, obviously this becomes important for things like data injection, those injection vulnerabilities that we'll talk about shortly. After we get done with that, and honestly, we talk about doubling back in that Circle K framework on a daily basis. I build a list of review items or risk assessment. I perform kind of a mini threat model constantly as I'm doing a code review, right? Because I know where, as I build my knowledge of that code base, it's going to become more prevalent or more things are going to pop up that could affect the risk assessment that I've done and where I should prioritize my time. The reason that we want to start from a behavior profile is because it gives us such a good idea of where we should be focusing our time. Right? Even before we've dug in and we found where the authentication and authorization routines are, how input is being handled, all that sort of stuff, we should have a threat model of what the worst thing possible to happen to that application could be. If we understand that, it's a lot easier to focus our time and prioritize our efforts. So we're going to utilize our gain knowledge here to identify those risks and threats and actually build out a mini threat model. And I don't mean you have to go through a whole formal threat model with all of the threat actors and everything like that, but we should at the very least know what those main threats are. Okay, so for example, right? I mean, typically we pull out grep, but I've actually got a code base up right here. I've just pulled it up in Atom, so it's not Java, right? I guess I should say that. Where would be the first thing, where would we turn to first here if we wanted to start to build out a profile of this application? Somebody just gives you a code base. What is it that I'm going to look at first? README, good. Everyone's paying attention. That's awesome. And I can't see that very well. All right. So this gives us some indications of what the application does. The developer's actually been a little cagey here because they didn't give us a lot outside of just running. But it does point us towards a few things. So if we're looking at a behavior profile of the application, okay, what is the purpose here? Right. All right, good. It's an intentionally vulnerable task manager. So it's some sort of task management application, projects and utilities and things like that go into it. But it also gives us a couple of other things. I mean, there's going to be some sort of administrator or other things. We can kind of pull some indication of what the behavior profile here is. Oh, great. Test 1, 2, 3. That's awesome. That's probably something I need to look at later if the passwords are that simple. MySQL I'm seeing mentioned, pip3, Python. All right, so I have an indication of I can start to form a profile of the application just by looking at the README. And you may do this naturally when you look at a code base for the first time or you're doing an assessment for the first time. But we want to start document it. We want to formalize the steps that we're taking here. So I'm gonna mark down at this point. Okay, it's a task management application. If somebody can access a task that they shouldn't be able to, or they don't have permissions to, that's probably the bad thing. Exposure of those details, if there is a sensitive project that's hosted in the application, that's a risk I should be aware of. So I'm going to start building that out in the notes that I'm taking. Anything else here that stands out? If I'm looking for third-party components, where am I going to look? And I don't need you to be experts in Python for this. What do you think? We've got startup. Requirements. Yeah. I mean, if you know Python, that's probably where you're looking, as it is. But if I don't, at the very least, I'm like, oh, there's an install here, and it's saying requirements.txt. That's probably where I should jump. And if we look at requirements.txt, right? Oh, sure enough, I will. It's not really locked. It's Django. So, okay, at this point, we know it's Python and Django. The manage.py gave that away a little bit. But we do have MySQL as a backend. So all the SQL injections that go along with MySQL, that's what we're going to be looking for. And we can start to build out more of a profile of the application. We can dig up more items in there, like if we were to look into unit tests or something like that, right? This task manager application. Like forms, migrations. Fixtures are always interesting, like any loaded data, right? Oh, users, of course, right? Because it does just start to give us indication of how the application is built, what the developers have put together. We've got the groups that are associated with it. Okay, there's the 3 groups. That's the rules that I wanted to know that exist in the application so that I can use that later on as I'm testing for authorization issues. So admin, project managers, team members. Okay, great. That seems to be fairly straightforward. So I want to document all this, and that's what that notes was that we looked at earlier. Okay, so once we've gotten to this point, we have a pretty good understanding of what the application is, what it does, what technologies are in use, and we're going to start digging a little deeper. So information gathering at this point is actually more of a technical information gathering. I want to figure out what the application looks like from a technical perspective. How is it accomplishing those tasks using the technologies that we've identified? So we're still trying to understand the application at this point. Don't dig in too quickly. So harvesting extra data, we're going to create an application map, and we're going to identify authorization functions. We're going to figure out how the application identifies the users as they're coming in. That's going to give us something. And then we want to know where the application sends data, what the map looks like, what the endpoints are that exist. We don't want to jump down the rabbit hole too quickly of what that application endpoint does outside of we know that it exists and there should be something there. And we're going to use the risk model that we've already created to pull out the interesting endpoints. So we're going to map, right? At times, this list can be very small. It can be very large. These are just some of the examples that we use to identify URLs, right? Or identify entry points into the application. If we think about applications, from a high level, they're all just some sort of a state engine, right? They have input that they take in, it does something, and then it sends data out. That's it, right? Like they just change the state of data or they change the state of something based on inputs that are given to it. So all applications have some sort of an entry point. So we're calling them endpoints here. It's like the URL endpoints is realistically what we're talking about. But there's some sort of an input that comes into the application. We do something and then we send data out or we perform some action. So the framework itself can be used for any of these different languages. Again, it's language agnostic. I did call out Android here because there's places that we want to look for each of those technologies. If you have built an application with that framework, even if you weren't familiar with it before, you should know where the input comes in at any given time. Now, so we can use some shortcuts to get the route information out, like rake routes, like the show URLs function for Django. But some applications aren't that well formed, or some frameworks aren't that restrictive. And so it can be anywhere in the code base. It just depends on how disciplined the developers are. Endpoints typically have those three qualities listed there. There's some sort of an authorization filter. That's why we're going to talk about decorators shortly. They process some logic and then they access data. So we can map that out fairly easily. There's some sort of routing as something comes into the application. Either the user's authorized or not. If they are, then we perform some sort of processing logic, accesses database. It may call an external service, do something else. And then there's a loop that actually goes back to the user there. If we look at Node.js, for example, right, it's very free form when data comes into the application, right? It can be index.js, app.js. It's however you start up the JavaScript runtime, but there are route definitions in there. We've got .get and .post. We'll look at those in a second. The last call in the route definition is actually the function that's being executed based on those route definitions, and then there's middleware somewhere in there as well that can do the authorization. So in this case, our formula is pretty basic. If we're trying to determine what that Node.js application does, we're going to use the IDE at this point, and we're actually going to use some of that grep, but we're not going to grep out for vulnerabilities. We're grepping out for functions of the application itself. We're looking for all the GET requests, all the POST requests, all the delete requests. Now, if I'm looking at a very complex application, there could be 200 or 300 different endpoints. I've looked at Java applications that have had thousands and thousands of endpoints. It's very difficult to actually say, hey, I'm going to look at all of these in my 3-week period. So instead, what we did was I identified which of the routes were security centric. You'll want to dump them all out initially so you can perform that analysis based on the risk assessment that we did previously. Closer look at JavaScript or a Node.js example. We found app.get. The endpoint, the URL that's being called is dashboard. It's got an authorization function in there, is logged in, so it's actually checking to see whether or not the user is authorized before they can get to the dashboard. And if they are authorized, if that comes back as true, then it's sent to this session handler display welcome page. It's pretty easy to understand. There's not a lot of security concerns with that, but right, it's giving us an indication of how the developers have put the application together. Django is very prescriptive in how things are set up. URLs.py, those are the different endpoints that exist for the application. There's decorators, but those are all within this views.py file. Which is actually called from urls.py. And if the decorator is, login required or, whatever, that can perform the authorization function for you before things go further. So this example, it's very similar. I mean, it looks pretty close to what Node is, and Rails and a lot of the different applications will have some way that they do this same call to set up all these endpoints. So anything that hits this task manager endpoint is actually including task manager URLs, and that's the namespace that exists there. So if we look, let me see. I'm going to actually pull this up. So we've got task manager URLs here. And what you'll notice is that there is no, like with Node, we had a get or a post request that were actually defined somewhere else. Within this one, we don't. The view or the get or post is actually in the views file, like the download function here. That's where the application determines whether it's a get or a post, which is fine. But there's no authorization information here either. We've got to dig in a little bit further to views.py to actually see what the authorization looks like. So here we have manage tasks. You'll see there's a login required decorator. That's going to be important to us as we move throughout the rest of the analysis. Okay, so we're going to call that out as we move into it. We should be noting this in our documentation. We're going to identify those authorization functions. We just did that. The importance here is that we've got a later step, a later section of the framework or the methodology that actually steps into the authorization checks where we will go down that rabbit hole. But right now we just want to know what it is so we can use that later on. It's still about getting to know the application better. We want to know how users are identified and authorized to access those endpoints. So we're going to attempt to identify patterns and anti-patterns. Okay, login required. That's great. What are the endpoints that don't have login required? We'll probably start to map that out. We'll create a list of all the endpoints. And then what are the purpose of the different decorators that exist? Like CSRF, that's a security function. There's sometimes decorators or other things that are built into the middleware that we want to be aware of in this stage. We've got to identify what that actually is. Yep. Okay. As far as patterns go, here's an interesting one. Again, this is dynamic though, but we should be able to see this in the code as well, right? This is an assessment that I did on a .NET application. We noticed that there was a response pattern here, like we went to it was like a dashboard, an admin dashboard that we could access, and normally this is what it would look like. Are you okay? Okay. But what I was seeing was something like this in Burp Suite, right? That's a really long length for a location redirect. That's what 301, 302 means. It's doing a redirect somewhere else. And I was like, wow, this is strange. But once you popped open that actual request and response, what I saw was the admin dashboard, like the location request headers, and then underneath it, it actually rendered out the entire admin dashboard, even though it told me to go back to the login page. I was like, okay, that's strange. So all I had to do was take Burp Suite, modify the response, and I could actually log in or use the application as an administrator, even though it was telling me to redirect. And it came down to a slight issue in the code. Whoops, I'm getting killed by a fly up here. Where the redirect function in .NET has this bool end response that can be sent back to it. So basically it tells the application, hey, I want you, and by default this is true, but for some reason it was set as false in this application. Maybe the developers just didn't understand what they were supposed to be doing and how location redirects work. But if this is true, it actually halts execution and returns right when the redirect is called. If you hit false, it says, oh, okay, I'll set up a redirection in the HTTP response, but I'll continue execution of this page. And you wouldn't necessarily see this or know this looking into the application, but during this phase of the methodology, what we're looking for is anything that is security-centric, that is used as anything that is security related that is used in the authorization of users, right? So if a user is authorized to hit that page, they shouldn't be redirected. If they are not authorized, then they should be redirected. But this sort of an indicator here is something that we should be aware of. So redirects are something that we're going to be looking for. Okay. So that actually brings us to, we're going to skip here. I've got 10 minutes, so we may not step into too much code. Like I said, we're trying to jump into a lot of things here. So that steps us to checklist and reviews. And there was a whole list of items that we wanted to get through, right? So there's authorization issues, authentication, auditing. Tell me what the difference between authentication and authorization is. Yes. Who are you? What are you allowed to do? Exactly. So those are fairly critical pieces of analyzing any source code. Most applications have some sort of a login function that exists. Authorization, because we've already talked about the decorators, we're going to do that first. We're going to analyze the application for role enforcement to see whether or not vertical or horizontal authorization checks fail, or if they are indeed implemented properly. This is where we're going to talk about things like insecure direct object reference, IDOR, access control issues, privilege escalation, mass assignment, business logic flaws. If you think back to the old kind of like price manipulation flaws that existed where you could change a hidden parameter as it was being sent to an application and change the price. Hey, that's great, right? For a specific product. But the issue here is it's all these authorization things that we want to identify in the application, right? Mass assignment, is anyone familiar with mass assignment here? We do have a few. Good. Okay, this is my favorite, like, developers are lazy vulnerability. Not really. It's just an easy way to actually take a request body and update a model within an application. The problem here is if the user object actually contains calls to like is admin or other things, if the attacker attaches extra parameters to that request.body, they just get processed along with everything else, right? And this is the actual vulnerability that ended up at the creation of the security team at GitHub. Because 4 or 5 years ago, they had an issue with Rails that was where when you updated a profile in Rails, like the user, like the built-in, I can't remember if it was device or not. Ken could talk to it better. But anyway, so this vulnerability is an authorization vulnerability because we're allowing users to update items within a model that they shouldn't have access to. So there's more about it. You can read up on mass assignment if you want to. So here's we're looking at a piece of code out of Django in this authorization example. What you'll see here is, and this is very true to life, we go down a lot of rabbit holes when we're doing a code review, and sometimes it doesn't result in anything, and that's good for the client. That means they've done things right. I mean, it's bad for us, not necessarily, but yeah, probably makes you feel like, a little bit like you should change your job. Anyway, so login required. This to-do is actually, for users that are already accessed or already have logged into the application. It passes in a to-do ID. Initially, this looks like it's vulnerable to insecure direct object reference until we look at the actual lookup, the objects.get here, because it'll pull the to-do ID, but it makes sure that the owner is the request user. So there is not a vulnerability per se in this, but these are the sort of checks that we're going to be performing. We're going to look at all the sensitive endpoints, and we're going to see, number one, hey, does a user have to be authorized to get there? And can they actually retrieve the data that they should be able to, or more than they should be able to? That's the check that we're going to be performing now. Authentication, very similar, but we are confirming identity. The two pieces of information we typically use when confirming identity are username and password. Is there anything else that we use to identify users?
Certificates.
Okay, certificates, biometrics, yes. I heard one more over here. Session IDs. I would argue that we actually identify users by session more than we do by username and password. When we look at the holistic amount of traffic that we use to identify users, it mostly is some sort of a session ID, a cookie object that we use to call them out. So that piece of information is important to us and how it's actually protected. So any time that the application establishes user identity or ties a user to a specific session, they're doing that via some sort of a mechanism, and that's got to be protected properly. So anything that can be used to either bypass that or determine what those tokens actually are is what we're looking at in this phase of the methodology. So the vulnerabilities here, broken authentication, user enumeration. We see user enumeration all over the place, especially in pages that that developers forget about that are used to establish identity. So your forgot password flows, your reset password flows, your sign up flow, anything like that where you're actually comparing and trying to figure out who a user is, that is going to be important in this phase. Brute force attacks. So what is the flaw here? It's obviously user enumeration, but why? Yeah, invalid username versus login failed, right? So we're giving an attacker a positive negative response. If we look in the code for this, it's fairly easy to pull it out. Let's see if we can actually log in. Yeah. Okay, never mind. I can't see it right now. And I've only got a couple minutes left. But it's actually, it's very easy to see that in the code when the flow, you look at the if-else statement, because it's checking to see whether it's looking up a user first and returning before it actually checks the password. And then we've got two different error messages that are being returned in this case. Oh, never mind. I had it right there. Dang it. Okay. So yeah. In this case, you'll see, right, like it's returning invalid login, where it's returning something into this template, and invalid username. So there's two different messages that are being sent to the user for this user enumeration flaw. Okay. So we're going to build a list of checks. So in this phase, and this is it. Like we build the checklist and then we actually perform the reviews for each of these different security functions. Auditing is a log that we're actually looking for, like how does the application log the data that's going into it and out of it, and what a user is actually doing. You're checking that sensitive data is handled appropriately. One of my favorite flaws to find during auditing is the logging around authentication, right? A user is attempting to log into the application. You're reading the log and you see invalid login, user Seth, password 123. Invalid login, password Seth, password 234. Invalid login, password Seth 345. And then successful login Seth, right? So if I was an attacker or if I was a malicious insider, had access to the logs, I could actually see, hey, it looks like this person has just changed their password from 1 to 2 to 3, whatever it is, and actually be able to ascertain what their credentials are. Logs should have everything in them that is necessary for forensic activity. And if your application is not logging that, then it is a problem. We see a lot of developers ignore this and think that Nginx or something else is going to handle it for them. But you've got to put some sort of thought into it, whether or not the application needs to have these logs in them. This includes everything from information leakage, like I said, debug messages, to just insufficient logging, like they're not doing anything. Here's an example, and this actually introduces a different vulnerability as well. This is a to-do application. We're creating a to-do, and in the log section here, you can see that we're identifying the user that's actually being logged, and that's great. But if we actually look at the logs themselves, where it's using this simple log format up here, you know what we're missing there? It's actually a timestamp, right? That's going to be that should be a problem, right? If you're trying to figure out what a user actually did, you just have a big old log that says this person did this person did this. You can't tell who did what when it really comes down to it. Okay, so that brings us to injection. I think we're about done. We got about 4 minutes. Okay. And I do want to take a couple of questions. So we'll just, I will push these slides out there and the framework as well. If you've got questions, you can hit me up on Twitter. Obviously, injection, this is input validation, output encoding. This always gets fun because we see things like SQL injection and SSRF, redirects, everything else that's associated with those typical input validation vulnerabilities, right? So there's some shortcuts that we can take during this phase. During our initial application profiling, we should have identified what sort of backend was being used, and at that same time pulled up the documentation to see how someone could manipulate that backend in an insecure manner. So for Django, or for Python, we've got this .raw function that can be called, and obviously this is vulnerable to SQL injection because we're taking email here directly from the request post that's being sent to the application. So yes, this is vulnerable to SQL injection. We should be able to identify this, but only if we had decided that we're going to trace through forgot password. If I'm doing a Django or a Python source code review, I should have pulled this up and looked for everything that had .raw. So instead of looking for select, I've actually scoped down to these are the dangerous functions that could be used by the ORM to actually create vulnerable SQL injection. 2. Okay. Output encoding is very similar. As we're looking for XSS, and we see a lot of templates that aren't necessarily, it makes it really difficult to know whether XSS exists within the source code. If you can run the application, but you still can identify this as long as we know, hey, this is an EJS template. The problem that we have is this minus sign. What does that minus sign actually mean, right? It's not like React, where React tells you if the developer is trying to set something insecurely in this output encoding, they have to actually use dangerously set inner HTML, right? It's very obvious that there's a problem there. In this case, the minus sign tells EJS that it should not output encode, right? So it should not HTML encode these variables. The only difference there, the equal sign is the one that should HTML encode. So it's going to be kind of hard to actually visually see that unless you've gone through and identified, hey, these are the templates that are being used. I know what cross-site scripting, or I know what output encoding looks like in that templating language. Okay. At the same time, when you're doing this injection or this portion, you're going to want to do a source to sync trace of everything that's coming from the user, where it's going. And that includes a whole bunch of diagrams like this. You can build this in your head, but you don't necessarily have to. So the other 2 phases, and I know I need to wrap up here, cryptographic analysis and configuration review that we call out specifically. The vulnerabilities that exist in there, you can go through and read, but realistically it means that we're trying to give a complete coverage of the application. You're going to apply this methodology. Let's see, okay. So to the application based on your risk assessment, and you're only going to apply any of these as they are appropriate for the time that you have and the application itself, the risk that's associated with the application. Like I said, we know this works. We've developed it over the last 15 years of actually doing source code reviews. If you talk to anybody that's in our class that has actually implemented it, does it well. If you want to learn more, hit me up on Twitter. And but thanks for having me. Thanks for coming and listening. I know it's a lot of information. I'm trying to shove a lot down your throats. So hopefully it was somewhat useful, but I appreciate it. Are there any questions?
We can. Well,
do we have any time for questions?
Round of applause for Seth Law. That was absolutely fantastic. Thank you very much. It's hard to get through a whole framework within a short time frame, isn't it?
Yeah.
But I strongly encourage questions. We do have time. So if anyone has any questions they want to ask, there's one just down there. If I could encourage you to also stand up, that way you can be seen as well.
So I understand that source code scanners are not really code review. So
okay, good.
But then most of the time, the challenge when you're running a large team where you have, many applications, many developers, is that you don't have time to do all this what you just mentioned.
Yeah.
So how do you see the importance of a code scanning tool to assist you or maybe complement and speed up some of the process?
So when I've seen them implemented properly or effectively, it's been very targeted, right? So something inside the CI/CD pipeline, like if you look at something like SonarQube, like how they're actually trying to do very quick analysis on a on a specific vulnerability. So one of the organizations that I worked for, that's what we did. We took Fortify and they wanted to roll it out across the board. We put it into the build process, but we only told Fortify that we wanted to know about cross-site scripting vulnerabilities and like 2 other things because it was just too much information over the top of that. And then once those ones got satisfied, we started adding more. So it's like this slowly, I'm rolling out the automatic tools and not just throwing everything at it and having my guys that are doing source code reviews depend on that as their tool of choice for doing a secure code review. Does that make sense? Okay.
We have one question there. Do you still have a question?
Yeah, it's pretty similar, but yeah, I've been in this situation that I had to do code review for an application that I really didn't know anything about that.
Okay.
But yeah, the same question. So if you're in an organization with lots of projects and lots of applications going live every day, so how do you scale this? How can you do all this analysis and all these things for all of these applications?
Yeah, that's a really good question. I mean, most of the time I step into an organization, I'm coming in as a consultant, right? And so they give me, 2 weeks to perform that sort of analysis. What I've seen effective, and I didn't have a slide up in here, but we talk about it in the course, is doing something that's very kind of pull request related. So instead of analyzing, hey, I'm going to look at this whole application and all of these different items, I'm like, hey, you just changed something with authentication. So that's the only thing I'm going to look at is this small portion that's carved out. If you have a big enough, or if you have a product security team and you start to specialize those teams to the applications as they're coming into in for the reviews, then it becomes less of a, hey, I have to go down and perform all the application overview. I have to figure out how the application works. But that's where you would be doing something like a pull request review rather than implementing the full framework every single time.
I think we had one more question down the front here. If you can't,
go ahead
as well, mate.
So in addition to what she asked, I just want to understand, like in DevSecOps world, like, how we can perform this kind of, analysis alongside the integration of SAST with CI/CD.
Alongside, and like I didn't really get into it, like during the configuration review, we definitely use the SAST tools as more of a sanity check, rather than this is the process that we use to perform an analysis. And there are some good things that come out of that. And I don't want to discount that, but what I want to get away from is this idea that a secure code review equals a SAST run and analysis of the SAST results. Okay. And come up and talk to me later. Like, I want to make sure I answered that question fully, and I don't think I have. So,
were there any other questions at all? I think there's one up.
Okay.
There.
Hi, Seth. Thank you for the awesome session.
Oh, thanks.
I have just one question, and that is with regards to the pen testing activity. How much burden does the pen testing takes off the code reviewer?
I would argue they're complementary, right? Like I do like to do what they call like a hybrid assessment, right? Where I've got both code and a running instance, so I can validate. But I feel like they're separate activities and they both need to be performed. I know like PCI and some of the other organizations will give you an either or that you can perform. So they just want to make sure you're doing something security related. If you're really serious about security, you should have people performing code reviews and the dynamic assessments going on. It's just like, Ken talks about this all the time with GitHub, how they have his team that does code reviews, but they depend very heavily like on the bug bounty program to find really, really hard esoteric vulnerabilities. They use the code reviews as, hey, we're going to go catch all the easy stuff so we don't have to pay the bug bounty researchers for it, and to make sure that we're covering our basics. That's what code reviews are about. We're covering the basics of what we should be doing. Like if somebody has some really great way to exploit a server-side request forgery that takes advantage of a framework, I'm not going to catch that as a code reviewer. I'm going to catch the SQL injection, and I'm going to catch the little configuration issues, and you can't expect the code reviewer to catch all of that. So I would argue that it does relieve some burden, but if you're not doing both, you're really not taking security that seriously, right? We can argue about it later, though. That's fine.
Thanks.
I suspect, you could kind of argue at that point to death, really. But the end of the questions, we're running a little bit over into lunch, but there's some really good questions floating around. It's a really good topic as well. So I believe there was one up there.
You have another? Yep.
Did you want to just yell it out and maybe we can just repeat it on stage? No, okay. What we might do, if it's okay, just come down after.
Come on down and
so we've got lunch.
We can chat.
We come back, I believe it's at 1:30. So we got Frenchie coming up talking about K-Rail, a tool that he's developed for Kubernetes. Awesome stuff. So thanks everyone for hanging about, and thanks everyone for the lovely questions, and have an awesome lunch.